So there is something called as levels of abstraction in the DBMS. So let's look at what it means. So there could be multiple users to your application, right? Let's say you have some banking application, and as an end user I am actually opening that application in my smartphone and trying to do some transaction in my, let's say, mobile banking application app. So now if I am doing that particular transaction, I really don't care about what is the table in my database, what the data is being stored by DBMS and things like that. I am just interested in getting the transaction done, let's say transferring some amount to my friend. So that becomes something called as an external or a end user view, right? So that becomes kind of a abstraction level 1. Then there is something which is at the next low level, that is called as a conceptual level data, where I am not really interested in knowing if the account holder's data is, let's say, being stored in 10 different tables. I really don't care what those 10 tables are. What I say is one block saying account holders data, second block could be something called as banking related data and things like that. So that becomes much at a conceptual level or a logical level. And then there comes all the details, which is like account holder information, its name, his user ID, his password, his address information is stored in one table. His different accounts are stored in, let's say, in a different table. So that becomes the detail level data, which is at the physical level stored in your hard disk. So that is actually something called as physical level or internal schema, which goes into your database. So these are the levels of abstraction in your DBMS. DBMS provides something called as data independence. And what does it really mean? So what it means is, let's say I want to change a name, or let's say a birth date on a account holder information in a bank, and he has a savings account in the bank with such and such balance and other things like that, his account number, the date he opened the account and things like that, right? So when I want to change the date in the account holders information, I really don't care about changing something at the higher level information. So that's a data independence. Meaning at the higher level, let's say I have account holders as one of the higher level data block, and I have banking details of that account holder as a second block. So I am changing account holders information at the detail level, his name. The higher level block account holders remains as it is. So that's actually called as a data independence. What it means is changing something into database physically, right? It won't have any impact at the conceptual or the logical level. As we saw, like there are 3 levels of abstractions, like external view, conceptual or logical view, and a physical view. If I change something at the physical view, there is no impact on the conceptual or logical level. So that is what it means by data independence in the DBMS world. And this is the DBMS structure. So any DBMS, right, let it be MySQL or PostgreSQL or Oracle, anything like that, they all actually have similar kind of a structure, right? So if you look at the left corner, there is something called as an application, which is interacting with DML compiler, and then the application is also interacting with something called as stored data manager. The end user can also interact with directly with DML compiler and query compiler, and then the DDL can interact with DDL compiler, and then in turn all of them are actually interacting with the lower level, physical level, where the data files are stored, and then the data dictionary is stored. So let's look at from the right corner, DDL. What DDL is? It's a data definition language. So when you are defining your table, that for storing an account holder information, I need an ID with some data type, I need a name, I need his birth date, age, and things like that. When you are defining that, that is your data definition language. So in DBMS structure, anything you are writing as your DDL is accepted or interacted with something called as a DDL compiler, which will check what you are actually telling to the DDL compiler. It will actually look at whether the syntax is correct and things like that, and then it will send it back to the lower level, which is a physical level. DML is nothing but a data manipulation language. Let's say if you have a banking application and it is trying to do some manipulation on your data, it is sent to a DML compiler, and that goes through something called as a query compiler, which looks at query syntax, whether it is fine or not, and then it interacts with something called a stored data manager, which in turn interacts with the physical level data storage. End user can also, the application can modify your banking data like account information or changing your balance and things like that. But outside of my application, I can use some tool to interact with the DBMS. Like we said, there could be a query language provided by the tool, by the DBMS. So that also goes through the query compiler. Then the query optimizer. What is query optimizer? Is based on what you are asking to get or update into a database. There is a program running in the DBMS which will optimize your query to give you a better performance. That is what is called as a query optimizer. And then it goes to the stored data manager to the database level. So this is the overall DBMS structure. And here are the definitions we talked about in the last slide. DDL compiler is actually, it processes your definitions of your tables, like they call it a schema in the DBMS world, and it includes metadata information such as the name of the files, data items, etc. Then where the actual file is stored, what is the mapping information, and if there are any constraints. For example, if I am opening an account in the bank, my birth of date can never be empty. That becomes a constraint. So if I define that constraint, the DDL compiler is going to check whether each record getting stored into my account holder information has a birth date or not. DML compiler and query optimizer, they are actually, as I said, data manipulation commands, data manipulation language commands, such as you are inserting a new record, updating existing record, deleting or getting the data from your application program. They are all sent to your DML compiler. They are compiled like your C program is being compiled for syntax check. Similarly, your query language or the query language being sent by your application is being compiled, and then the user's access and everything is checked. And of course there is a query optimizer we talked about, right? It will actually optimize your query to execute in a best possible way, and then everything is sent to your data manager. The data manager is actually a central component of the DBMS, which is also called a DCL or database control system. And the main functions of data manager are, it actually converts all the operations or queries coming from the application or a different program like a query language tool, and it optimizes that, and it actually looks at the logical view and the physical file system. And then it controls the DBMS information access that is stored on the disk, right? So if a user ID and is not does not have access to the database, it won't allow to log in and fire the queries. So as we have like the main memory in the computer, right, how to handle the buffers and the cache information, everything is handled by this data manager. All the constants that we talked about, birth date cannot be empty, right? All these consistency and integrity checks are done by data manager. And then it also helps in synchronizing the simultaneous operations. For example, two people like logged in the banking application trying to retrieve or modify or update the data, the data manager will take care of simultaneously handling those operations from these two different users. And when I want to take a backup of my database or backup of my data, and if I want to recover at some point of time that particular data, the data manager takes care of it. So we talked about data dictionary. It's actually a repository of the description of the data in the database. So as I said, right, account holder. So what are we store in the account holder information? The age, the name, the birth date, the address, the city information, and things like that. That whole repository is nothing but a data dictionary, and then it contains list of tables, the names and attributes of the each table. So account holder information could be one table, his bank account details could be another information, his transactions transfer data from one account to other account could be another table. So all those list of all those tables, its names, its attributes, constraints on it, the relationship between these tables, everything is nothing but a data dictionary. And data dictionary generally not seen by the end users. Even the technical people who wants to see the data dictionary, there are specific metadata tables that you need to access in DBMS. So data dictionary has its certain functions, right? It has, it gives a control to a DBA. So DBA is a new term here, right? Database administrator, who is administering the functions of your DBMS, your users and things like that. That becomes a DBA. And the data dictionary gives a greater control to the DBA. Right? Then data dictionary is also kind of a documentation of your database design. It provides information to the users about which data is available and how can it be obtained. Then it helps in identification of the organization of data irregularity. And it's a very essential data management tool in the DBMS world. Data dictionary, the DBMS has something called as data files. So all your data logically see stored in a table, but it ultimately goes into a database which is comprised of data files. And the DML, as we said, right, it's a compiled version. So as your C program is getting compiled by your compiler, in DBMS world as well, or your DML statements, DDL statements are compiled by the compiler, and then it is optimized by the query optimizer. End users we talked about, right? If I am using a banking application on my smartphone or on my laptop, I am not really interested, or I'm not really aware of what is going in the background in the database, and what are the different utilities being used, and what is the DBMS being used, whether it is MySQL or Oracle and things like that. That becomes an end user of the application. So that's a terminology here. So I think we have covered what what data is, what database is, what DBMS is, what kind of different DBMS are available as of today, and how the structure of a general DBMS looks like. In the next section we'll go through the second chapter. Please give me your feedback, comments. If you have any questions, please ask me. Subscribe to the channel, and as soon as I upload a video in a couple of days time, you can go through the next video as well. Thank you so much for your time. Bye for now.